In this video, we'll go over how to upload an energy model from IES-VE. IES added the Python API in VE 2017. Models created using VE 2016 or earlier will need to be updated to a more recent version, and this could involve reconfiguring some systems and rerunning the simulation. The API allows users to write scripts that interact with the VE model and Vista results files. We'll use this interface to extract data from the model and simulation results files and write them into a format that can be uploaded and read by Compass. First, we'll need to download the script that will run in VE. A link to the GitHub repository is available in the video description and on the Compass website. We'll save the script somewhere convenient, for example on our desktop, by clicking the Raw button, then right-clicking and hitting Save As. Now we'll move into IES-VE. We begin with our model open in VE and with our simulations completed. There are a few variables that we need to gather manually and provide when requested by the script. I suggest writing these in a simple text file that we can copy and paste from when they are requested by the script later on. First, we need to make note of the site orientation for Model IT, as this is not currently accessible by the API. Next, we'll need to create a list of the outside air nodes and a list of the room supply air nodes. We open Vista Pro and open our proposed simulation results. We can view these nodes by selecting the appropriate HVAC network from the Model Browser dropdown. The outside air nodes are pretty straightforward. We move through all the systems and make note of all the nodes immediately after the system inlets. We separate the node numbers with commas. Spaces are not necessary, but can be handled. For example, in this system, we add nodes 132 and 320 to our list. We continue this process through all of the systems. 321 and 805. One, 871, 837 and 807, 869 and 844, 906 and 882, 'We end up with a single list of all of the outside air nodes. Next, we need to record the room supply air nodes. We want to include all of the treated air that is being supplied to the room, but we do not want to include untreated transfer air. For example, in this system, we would use node 183. We do not use node 184 because this would include the transfer air coming in node 317. Similar case in this system, we're going to use node 446. Easy one here, 65. 875, 824. 856, 893, The script will run through all the rooms within the multiplex and compile the data. If this model includes a reference building, we'll need to repeat this after opening the reference model results. This is important because, even in the unlikely case that we're using the same systems in both the proposed and reference, the nodes are not guaranteed to have the same numbering in both simulations. Once we're finished, we should have a list of variables that look like this. We're now ready to run the script. We access the Python API, which IES calls VE script, from the Tools menu. The file list on the left shows the scripts that are included with VE. We'll add our script to the file list by right-clicking on this pane and clicking Add Script Folder. We select the folder where we saved the script and click OK. You should now see the script in the File pane. Click it to open it in the code editing window. We run the script by hitting the Run button, and you can monitor the progress in the output window. We enter the values when requested by the pop-up windows. The orientation, the outside air nodes, the room supply air nodes, and finally the proposed results APS file. At this point, how we proceed depends on if and how we modeled our reference building. If we only modeled the proposed building, we decline attaching a reference building. We'll be asked where we'd like to save the output JSON file. We're now ready to upload this file to Compass. If we're using the PRM navigator, we can extract the data from both models. Click Yes when asked if you'd like to attach a reference model. We now provide the required information for the reference model and select the reference APS results file. The script will continue with extracting data for the reference model. Once complete, it will prompt for where to save the output JSON file. The script will produce one output JSON file that contains the results for both the proposed and reference models. This is hinted at with a suggested file name ending in a both tag. In Compass, we upload this one file to both the proposed and reference models. Lastly, we have the case of modeling the proposed and reference buildings in two separate VE projects. If we did this, we will decline attaching a reference model. We cannot just pick the APS result file from the other project because the script extracts information from the model file currently opened in VE, as well as the APS result file we select. The output JSON file that we're now saving is for the proposed model. We will now close the VE script window, open the reference model project, and repeat the process with the reference model project. Remember that you'll need to get the room nodes and outside air nodes from the HVAC systems in the new model. Once the script finishes running with the reference model, we will again decline attaching a reference model. When prompted to save the output JSON file, we should change the suggested proposed tag to a reference tag for clarity. We will now have a proposed and reference result file to upload to Compass. If we run into any errors when running the script, we should first try restarting VE and trying again. If the problem persists, we can try checking the GitHub repository to see if there's a more recent version of the script for us to run. Lastly, we can send a screenshot of the error traceback to support at EnergyCompass.design.